So you must be sincere about all the subjects, not only the physics, but I also request my subject, means physics subject, a very tough subject for those students, those are not interested in math. So from my childhood times, or you also learn from everywhere, if a student interested in math, automatically the students also interested in physics. So two subjects are correlated each other, you know it. So first and foremost, my request, you must be try to interest in math as well as the physics. How can we interest in physics? Physics always try to explain it with the help of your surroundings and related with the other things, subjects. So you must sincere it. So what is science? My question is, what is science? Science is an organized, systematic and formulated knowledge obtained through observation, experiments and verification. So you avoid the remembering method. You always try to experiment it. You always try to observe it from your surrounding. Others you try to observe from your imaginary part, and verification. From those observation and the experiment, you verify it. So science is not, science means I always try to talking about the physics is not the remembering method. So you must try to observe it, experiment it and also verify it. And science, one subject is physics. Physics, what is physics? Physics is that branch of science. The physics is a part of a science subject, means science branch. Physics is that branch of science which deals with nature and natural physical phenomenon. So the imaginary part is a very few part. You see the imaginary part. You see all things are in your surrounding, means nature, and natural phenomenon means you see one example, lightning. It is a natural phenomenon. And you explain it with the help of physics. So you try to always explain it, always observe it and you verify it. You apply this method, you will be success. Otherwise, you try to remembering method, you will be failure, because so many formulas, theories, laws are there, you cannot remember it. It cannot be possible. You try to remember it by the trial and error method, means with the help of your practice, by trial and error method. If someone mistakes are there, you try it, again try it, you will be success. And you will be success in your life also. Now we see physics subject correlated with the other subject. You know the physics. So someone questions physics related with the chemistry, physics related with the math. You explain it. So many tools, mathematical tools are there, you use in physics. Suppose you try to solve one numerical application with the help of math, means mathematical tools, means by the integration method, by the differentiation method, so many numericals are there and you use the different mathematical tools. So, with the help of the mathematics, you can easily explain the physics. Suppose you consider chemistry part related with the physics. You know the atomic structure, crystal lattice, so chemical bonding, so many terms are in physics as well as the chemistry. And next is the biology. Biology, with the help of a X-ray, you use the crystal structure, you use the so many branches are there in biology with the help of, you explain it with the help of physics. And you know it, the astronomy, geology, so many science department, you know it, those are correlated with the physics. Astronomy, astronomy means you see the size of the moon, you see the position of the moon, you see the different object in our universe with the help of astronomical telescope. Am I clear? Yes or no? And also you know it, the geology. Geology means you see the crystal structure. This stone is that, this stone is that, this stone is react with this. So, geology also depends on the physics. Physics also explain the geology. Next part. The physics, different fundamental forces. Physics also explain the different fundamental forces. Fundamental forces, different fundamental forces. Suppose you consider, first is the gravitational force. Second is the electrostatic force. Third is the strong nuclear force. Fourth is the weak nuclear force. Okay, first is the gravitational force. Gravitational force, you know it from your class 9. The nature of the force, the value of the force, which part is the depends on this force, you know it. Everything you know it from your class 9. Okay? Because you know it, F equal to G M1 M1 M2 by R square. This type of force is the weak force, not the weak nuclear force. Forces are two types. Basically, one is the weak force, another is the strong force. Gravitational force is the weak force. It is the central force. It depends on different factor. And you know the G also. This is the gravitational force discovered by the scientist Newton. You know it. Electrostatic force. You see it. You will be see in class 12. Also you know from your class 8, F equal to K into Q1 Q2 by R square. This also the force of attraction, charge particle, attractive nature, repulsive nature, central force, weak force. You know it. Strong nuclear force. inside the nucleus. Inside the nucleus. Inside the nucleus, two particles are there. One is the proton, another is the neutron. So, proton has positive charge, neutron no charge. So, you know the similar charge, they are repelled to each other. But you see, according to atomic structure, the nucleus is there. So, they are not repelled to each other. What happened? Positive charge means proton and neutron, they are interchanged to each other and create a force to bind the proton and neutron in the nucleus, means nucleon in the nucleus. That type of force is called the strong nuclear force. It is only applicable inside the nucleus, not outside the nucleus, not anywhere. So, this type of force is called the strong force also. The rest of the forces are the weak force. Am I clear? Weak nuclear force, this also the radioactive element. Radioactive element, when beta decay, that time some neutron and electron and neutrino are formed from the beta decay time. That type of a force is called the weak nuclear force. So, this is the weak force, that and that also the weak force, and this is the strong force. Only you see inside the nucleus. So, those are the fundamental forces. Next, so many fundamental laws are there. So many fundamental laws are there. In physics, you see from your previous class, fundamental laws. So many fundamental laws are there. You know it. First, conservation of charges. That means, you know it from your previous class. Suppose iron rod. No. Suppose you consider a glass rod. Rub with the silk cloth, and by the rubbing method, you see the two type of charges create on those materials. First one is the positive, and this one is the negative. So, if you count it, if you see it, 10 positive charges are here. If create on it, that time you see the 10 negative charges are there. Or if you see with the help of the induction method, suppose you consider a charged particle nearer to the neutral object. Okay, you see the nearer part will be create opposite charge, and the further part will create the same charge. So, if you see, this side is create the 5 electron, that side will be create the 5 positive charge. Okay, am I clear? So, that is the conservation of charge. Second is conservation of mass energy. Mass energy. Conservation of mass energy, you know, from the famous scientist Einstein, the relation between the mass energy equal to mc square. M is the mass of the particle or the object, and c is the speed of light in vacuum or space. C is the speed of light in vacuum or free space, or the also that value also be the same in, we consider it in the air. So this is equal to mc square. Third number, conservation of energy. Conservation of energy, you know it. Energy only transfer from one form to another form, not create, not destroy. You know it from your previous class, work power energy in class 9. Okay. So the energy is conserved for the free falling body. You remember it. Energy is conserved for the free falling body. The total energy means mechanical energy at the top of its position is, suppose, a certain value. The kinetic value is 0, the potential value is a finite value. So total energy will be, suppose, a finite value. At the middle of its or anywhere, the total energy will be the same, equal to the, same as the top of its. When you see at the just nearer to the surface, the total energy will be the same. When it touch on the surface, that time the energy will be convert from one form to another form. That means you see the sound energy, the heat energy, so many energies are there. So energy will be transferred from here to there. Suppose you see lights are glowing. So electric energy change into the light energy, also the heat energy, so many energies are there. So energy cannot be created, cannot be destroyed, you only change its form. Okay. Next. Conservation of linear momentum. Law of conservation of linear momentum. So this term is new, you know it only the momentum, but in your class 11, you see the momentums are two types, one is the linear, another is the angular. So linear momentum means when the object is moving in a straight line or the linear motion, that time the momentum also be conserved. From your class 9, you know it, collision between the two particles, if you consider it, the two particles are collided to each other. After collision, the total momentum before collision already equal, but one necessary condition is there, if external force are absent. That means in the isolated system, always momentum are constant. Constant means no external force acts on that system. That time before the collision, total momentum is equal to the total momentum after collision. Next, you see class 11, the conservation of angular momentum. Conservation of angular momentum. If the object is motion is circular or the rotational, that time you use this term, and this type of momentum, angular momentum. Angular momentum, so here also, if the torque, absence of torque, means absence of torque of the system, the total angular momentum before or after collision will be the same. I1 omega 1 equal to I2 omega 2 when the external torque is 0. You see second part in your physics book, the rotational motion chapter, you see the angular momentum also, conservation of angular momentum. Okay. Next. This chapter, rest of the part of this chapter means physical world. First chapter, chapter number 1. Chapter number 1, the name of this chapter is physical world. Physical world. Physical world. Just you know so many scientists, name of the scientist and the discovery of the things. Okay, so you know it, and rest of the part already discussed. Okay, and second chapter, chapter number 2. Chapter number 2. So again revise it. The chapter number 1, you know the basic concept of science and what is physics. Physics correlated with the other science subject, and different type of force, fundamental force, different type of laws you use in physics, and name of the scientist, you remember it and discover the things. Okay, those are the first chapter. Second chapter is the very, very vital, very, very important. You must be serious in this chapter, but you will not try to remember, remembering method, you try to apply it. Means you know from your surrounding and you use it. Those physical quantities, you know it only. Second chapter, the name of the chapter is units. Units, dimension and unit, dimension and error. So, units. From my childhood time, we only know the units. We have seen the class 9th and 10th level. So many units are there. So many systems are there. CGS system, APS system, and APS, CGS and MKS. Now, CBSE only follow the SI system, means International System of Units. International System of Units, not the centimeter, gram, second, not the foot, pound, second, not the meter, kilogram, second. It is the modified form of this. Meter, kilogram, second. This system, the unit of mass is kilogram, the unit of length is meter, the unit of time is second. But you see, each and every books, the name of this system, we use it only the SI system. SI means International System of Units. Those are backdated. But you also see different competitive exam. So many boards are there. So relation between the CGS, FPS and MKS, you also try to remember it. Because you know it, those are correlated to each other. Those are correlated to each other. Meter, 1 meter equal to how many centimeter? Small letter cm. 1 meter equal to 100 centimeter. Okay? 1 kilogram equal to how many gram? You know it. So those are correlated to each other, but this factor is the backdated. Foot pound second, British unit. But we also use those terms in different activities. You see, pound in unit also used at the time of Xmas. The cake, Xmas, you use the cake, that unit of the cake, that means the mass is pound unit, not the gram unit, not the kilogram unit. When you measure the height, that time also you use, sometimes also use the feet. When you use the, so many activities are there, you use it in feet, mean foot, and also the relation between the pound and the gram. 1 pound equal to, so you must sincere it. 1 centimeter, one feet equal to, so many terms are there. You, if you wish, you remember it, otherwise you left it. SI unit, the only units you know it, the mass, length and time. Those are not sufficient. So different activities, different physical quantities, we cannot measure it with the help of the 3 units. So new science, 1960. So many fundamental units used in our physics, not only the 3 units. 3 units means not only the 3 units, means the mass, length and time. The unit of mass is gram or kilogram. Fundamental is the kilogram. The unit of length is meter. Unit of time is second. Unit of temperature is capital T. Unit of temperature, Kelvin. K, someone user capital T. Unit of intensity of light, candela. Unit of current, ampere. Unit of volume of the gas, it is the mole. 7 are the fundamental units. 7 are the fundamental units. Those are not the sufficient. After this, 2 are the subsidiary units. Supplementary unit means one is the mole, one is the radian, another is the steradian. Radian means it is the unit of angle, 2 dimension and 3 dimension. You use in the degree. So Degree is not the universal fundamental, radian is the fundamental, and for the 3-dimension space, 3-dimension use, that time we use the steradian. That time we use the steradian. So my dear student, you must be remember it. Fundamental units, how many fundamental units are there, and how many fundamental units are there, and subsidiary units are there. Name of the fundamental units and notation of the fundamental units. Am I clear? So thank you, my student. Next day again I discuss you about the rest part of this chapter, and any queries from your side you must be discussed tomorrow. Thank you, my BMS dear student.